Hello and welcome to this quick demo of this project, which is hosted in the following link. This project consists of an application that lets us create customized diagnosis or classification models based on a neural network algorithm. So what we are trying to do here is classify a healthcare dataset outcome and predict whether a set of patients will have a stroke. We know ahead of time what the correct classifications are for each record in the dataset, and we are going to use the training dataset to train our neural network to hopefully learn and be able to predict correctly the outcome of the testing dataset. So basically, we can just play around with this application and experiment with creating different neural networks. So first, we can choose the ratio of training to testing dataset. I'm going to increase this number. Here, next we have to choose the data set we want to experiment with. So we have the original data set, which is imbalanced, and we have the oversampled version of this data set, which is balanced. So let's leave it as it is for now. So here we can choose the number of neurons in the hidden layer, the learning rate. We can decrease the learning rate, for example, so our model can learn better. Only when you increase the learning rate, we may want to increase also the number of epochs, but just leave it for now, so it can be faster. So here we can also choose the threshold. We can decrease the threshold. Let's run the model and see what results we're gonna get. So as we can see here, we have the execution time, the test accuracy, the average precision, the test precision, and the test recall and F1 score. So we can see here that our model has predicted everything to be positive. So everything to be positive, we have true positive and false positive. So let's try to maybe increase the threshold and see if the results are going to change. So now it's predicted everything to be negative this time. So increase a little bit the learning rate and see. So now the results have changed a little bit. We have the true negative, false positive, and this 1.45% of true negatives. The F1 score is 0.1. So I have experimented with the original data set, and the maximum score, F1 score I can get was 0.16, around this number. So that's why I did this oversampled data set. It just creates duplicates of the original data set with some algorithms. So there are many algorithms that can do this oversampling. Let's now try with this oversampled data set. Maybe with the oversampled data set, we don't need the threshold to be 0.3. It can even be 0.2 or 0.5. So let's run it. So here our model has predicted everything to be negative. We can also increase the threshold. Here we have the average precision. It gives us an idea of the threshold we can choose. So we can do 0.5 and see if the results can change. So still no, didn't change. How about we increase the learning rate? So here we got a good result. So F1 score is 0.74, which is good. The recall is almost 1, and the test precision is 0.5. So our model has predicted 34% to be false positive, and we have true negatives here and true positive. So we can still try with other values. Just to mention, for the oversampled data set, we have almost the same number of positive values as the negative values, because it was oversampled. So the algorithm has created duplicates of the data set in order to make it balanced. So yeah, we can try other values. If we increase the number of epochs, it's gonna take a little bit more time. So yeah, we can increase, for example, and make this to 500. So again, it's predicted everything to be positive. Let's again increase this one and decrease the learning rate. Let's see what we're gonna get. So here we have some good results as well. So we see that our model has predicted the true negatives, the true positives, and here we have false positive and false negative. So our F1 score is 0.8 and accuracy is 0.801. So yeah, so that's pretty much our application. It just, we can experiment with selecting or unselecting some features, increasing or decreasing the data set, the ratio, or you know, choosing those, changing the model parameters. So yeah, that was it, and thank you so much. Thank you.